Alright guys, today we're going to talk about fractions. Let's get into it. The first thing I want to cover is understanding what a fraction is. A lot of people have trouble with fractions, but remember all it is it just represents a part of a whole number. Okay? So if I have a whole circle here, this is one whole circle. You can think of it as a pizza or a cake or something. If I shade in 1/4 of this fraction, or 1/4, I can represent that with the fraction 1 over 4. 1 being the part that we're concerned with, in this case that's the shaded part, and then 4 being the whole thing. This whole cake or whatever is divided into 4 pieces. Okay, so we can express that as 1 over 4. The top number is called the numerator, and the bottom number is called the denominator. So we can represent things using fractions. So here, if I have a rectangle that's divided into 8 pieces and I've shaded in 5, we could express that as the fraction 5 over 8. You can also think of a fraction line as a division problem. So we could read this as 5 over 8, or we could read it as 5 divided by 8. It means the same thing. Then you can interchange them. So let's check out an example, and we'll use a fraction to describe this situation. 11 out of 15 of the math students received an A for the semester. So as a fraction, we're concerned with 11 of the students. So that's going to be our numerator, okay? And 15 being the total, that's going to be our denominator. Second example, Patty needed 3/4 of a yard. Well, that's essentially 3 over 4. 3/4, 3/4. There it is. Now let's take a look at simplifying fractions, and I'll show you a couple of tricks, but I'll show you the proper way first. And before we talk about simplifying fractions, let's talk about prime numbers. A prime number is a whole number greater than 1 that can't be evenly divided except by 1 in itself. So the first couple primes are 2, 3, 5, 7, 11, 13, etc. These are all prime numbers because there is no other number that could be divided out of that. A composite number, on the other hand, is the opposite. It's a number that can be divided by some number other than 1. Okay, so if we take a look at 24, for example, I could break that down a bunch of ways. We could break that down as 2 times 12, 3 times 8, or 4 times 6. So 24 is what's referred to as a composite number. Okay, so there's a couple of shortcuts we can use. The first one, when we're reducing fractions, and I'll come back to this prime number idea in a sec. I'll show you the Cadillac way, I guess. But a couple of shortcuts. Number one, a number is divisible by 2 if its last digit ends in 0, 2, 4, 6, or 8. Number two, a number is divisible by 3 if the sum of its digits is divisible by 3. And the last little shortcut, a number is divisible by 5 if the last digit ends in 0 or 5. So let's take a look at 450. Now this number is divisible by 2 because the last digit ends in 0. That's an even digit, so we can take half of that. 450 is also divisible by 3, right? 4 plus 5 plus 0 is 9, and 9 is divisible by 3, so we could divide this by 3 as well, okay? And the number 450 is also divisible by 5 because it ends in either a 0 or a 5, so we could divide this number by 5. So these shortcuts will help you, they're just going to help speed you up when you're reducing fractions. But kind of the best way, and definitely I would recommend this way if you want to kind of do it in one shot, would be to use the prime factorization method. So if we have 24, let's write that as a product of prime numbers. So we're going to basically do a factor tree, or a prime factorization is what it's called. So we can break down 24 any two ways. I'm going to do 4 times 6. Okay, 4 breaks down into 2 times 2, and 6 breaks down into 2 times 3. So these now are our prime factors. No other number could be divided out of these numbers. So 24 as the product of primes is right here. 2 times 2 times 2 times 3 gives us 24. So when you're reducing fractions, you kind of want to reduce the top number into its primes and the bottom number into its primes as well. And by the way, whenever you're doing this, I chose 4 by 6 to break it down. You could go anyway. 2 times 12, 3 times 8, it's all good. They all break down into the same number of prime factors. Okay? So let's take a look. Let me go back here for a sec. Let's say we have 24 over 4, and we want to reduce that fraction. Now 24 we've already broken down into its primes, so that's going to be 2 times 2 times 2 times 3. And 4 breaks down into 2 times 2. So here, because we have the 2 on the top and the 2 on the bottom, 2 divided by 2 equals 1, and we can essentially just get rid of it. I can get rid of this other fraction as well. So what we have left on the top is 2 times 3, which is 6, and then over the bottom is just a 1. So our answer would be 6, or 6 over 1 if you want it as a fraction. Okay, so that's kind of the idea there. Another idea that I want to talk about is equivalent fractions. We can basically scale up or down fractions as need be. The value stays the same. So here, if I have this kind of hexagonal shape and I divide it into 6 pieces and I shade in 3 of them, I could also express that as 1/2, 1 out of 2 pieces. Note that the shaded area is the same. It's the same value. Okay, so it doesn't matter. 1/2 is equivalent to 2 over 4, is equivalent to 3 over 6, it's equivalent to 4 over 8 or 5 over 10. All those fractions are equivalent because they all reduce down to 1/2. Okay, so if I divide top and bottom here by 5, I get 1/2. That's what we're talking. And in simplest form, remember, we're going to use this idea that anything divided by itself equals 1. That's going to help us out big time here. Okay? You guys don't, we talked about simplest form already. So when a fraction is not in simplest form, it can be reduced. And basically, the best way to do that is to divide out a common factor or do a prime factorization and then divide. That's cool too. So for example, here, if we have 25 over 40, notice that both the right digits here end in 5 and 0. So the 5 rule would apply. We could divide top and bottom by 5. 25 divided by 5 is 5. 40 divided by 5 gives us 8. And now this is in lowest terms. Okay? So, cross products. This is a great way to check and see if 2 fractions are equal. So let's say we have 1 over 2, or 1/2. Is that equal to 4 over 8? Well, what we can do here is we'll multiply the cross product. So we'll say 1 times 8 is 8, and then we'll go the other way and we'll multiply 2 times 4. In this case, both of the cross products are equal, so we would say that these 2 fractions are equal as well. So that's a great little check if you want to figure out if 2 fractions are equal. Okay? Just multiply the cross products. If they're the same, then you're good to go. Next, let's talk about converting between improper fractions and mixed numbers. Now, a proper fraction is where the numerator is less than the denominator. Okay, so proper fractions are things like 3 over 4, 5 over 9, 1 over 2, etc. because the numerator or the top number is less than the bottom number. Sometimes we have what are called improper fractions, which are the opposite. The numerator is greater than the denominator. And what this means is that we actually have more than one whole thing. Okay, so if we had, some shape divided into 5s, there's 2, 4, let's just say 5, for example, and we have 9 of those, well, that would be 2 of those shapes. Okay, so we have 5 over 5 here, and then we'd have 1, 2, 3, 4 circled in here. Okay, so 5 plus 4 will give us 9 pieces out of 5. Improper. So what we do generally when we have an improper fraction is we like to convert that to a mixed number. And a mixed number is where we have a whole number like 2 and a little fraction part together. So 2 3/4, 1 5/9, 22 1/2, etc. Carpentry and the trades use these kind of numbers all the time. So if we're going to look at 2 3/4, what that means is we have 2 full ones, 2 full squares in this case, 1, 2, and then we have 3/4 of another square. And that gives us 2 3/4. So to convert from mixed numbers to improper fractions, there's a little procedure. We're going to start at the denominator. We're going to multiply the denominator by the whole number. So 4 times 3 is 12. Then we're going to add on the numerator. So 12 plus 2 is 14. And then we'll express it over the original denominator. Okay? So 4 times 3 plus 2, that's going to equal 14 over 3. So always start at the denominator, multiply, add, and then you're good to go. Okay? To change from improper fractions to mixed numbers, essentially if we have 21 over 4, what we're going to do is we're going to old school divide the denominator into the numerator. So this is going to be 4 into 21. 4 into 21 goes 5 times. Right? 4 times 5 is 20. So if we were to subtract that, we would have a remainder of 1. Always divide old school so you get a remainder here. Okay, so 5, that's going to be our big number. Our remainder is going to be our new numerator. and the original denominator stays the same. So that's going to be 5 and 1 over 4, 5 1/4. How to reduce a mixed number or an improper fraction. Let's say we're going to reduce 125 over 5. Now right off the bat we could use the 5 rule here. We could divide top and bottom by 5. But I want to show you the textbook proper way. Prime factorization on 125, that equals 5 times 5 times 5. And 15 breaks down into 3 times 5. So we have all our prime factors here. And then notice what's going on. We can remove one set of 5's. 5 over 5 is gone. So we have 5 times 5 left on the top, which is 25. And we have our 3 left over. And now this is in lowest terms. Okay? If we have a mixed number like 4 and 11 over 66, we can just leave the 4 alone. Don't forget to include it again, but we can really just reduce the fraction part. 4 is a whole number, that's fine. So let's reduce our fraction part now. 11 breaks down into 11 times 1. 66 breaks down into 11 times 6, and we can cancel the 11's to get 4 and 1/6. Okay, so I hope that helps. If you have any questions, please let me know. Thanks.